Okay, I think I finally have everything working again. This is try number 472 to do a balance in chemical equations video. This is hilarious. Seriously, dude, I think you're overreacting. Signs of a reaction. Hilarious, plus a sad face. That's one that you need to add to your list. There now are officially 7 signs of a chemical reaction. If your Erlenmeyer flask has a sad face on it, that's also a sign of a chemical reaction. And since you're not laughing at this joke, there you go. Oh, yes, very, very hilarious. All right, today we are going to learn how to balance chemical equations. Remember that we talked about the law of conservation of mass, matter, and atoms yesterday. Mass, matter, atoms cannot be created or destroyed. So when we do a chemical reaction, the amount of stuff on the reactant side, the things that are around before reaction, has to be the same amount of stuff on the product side. So the way that we do this, there is no set of steps. There's no first do this, second do that, third do that. It is trial and error. For some of the more challenging ones, you may have to start over. You may finally get to numbers that just don't make sense, erase it and start over. That really is what you need to do sometimes. Erase it and start over from a different spot. I can give you a couple tips though that can help you to maybe be more successful at this. A couple of things to try when you're balancing chemical equations, and I'm going to work out some examples here for you. Begin with the formula containing the most atoms. So the most complex, the most complicated, the biggest formula. That is something that you can begin with. And also try making the odd element even. I'm going to give you an example of that in just a minute. But first, just a general purpose, how do we balance chemical equations? Split the reaction into 2 sides. You have to do this every single time. I won't grade your problems unless you do this. We need to do an element inventory. On this side, H equals how many? Our subscript tells us 2. Our coefficient, if it's not written, is 1, remember? So we don't have to write them, but we pretend like there are 1s in front of these if there isn't 1 there. So 1 times 2 is 2. Our O is 1 times the subscript's 2. On this side, make sure straight across from this H, you write H on the other side. H equals 1 times 2. 2. O equals 1 times 1, if there's nothing written there. 1. Here is our element that does not obey the law of conservation of mass, matter, and atoms. So we have to add coefficients. We have to change the numbers in front, not the subscripts. What happens if we change the subscript? Let's look at H2O. We need to have 2 O's on this side. That's when it would be balanced if it had 2 O's like this side. Why can't we just put a 2 after the O? That would give us 2 O's. H2O2 is hydrogen peroxide. It is not water. You cannot drink H2O2. Be very bad for you. So you cannot change subscripts. You have to change coefficients. So what am I talking about? Coefficients. The numbers in the front. Let me get rid of the ones that we've got. And now we can change the numbers in the front. We need 2 more oxygens on this side. 2 more oxygen. 1 more oxygen. We need 2 to match the other side. So we put a 2 in front of H2O. It does change more than just the O though. 2 times 2 is 4 H's now. 2 times 1, 2 O's. So our O's now match, but our H's aren't matching. So on this side, we can put a 2 in front of this H. 2 times 2 makes this a 4. And now if we look across, we've got 4 here and 4 there. So our H's are matching. It's balanced. We've got 2 here and 2 there on our O's. So our final answer then is 2H2O, 1O2, 2H2O2. The next one that we want to do is our odd-even mismatch. I'd like to do our odd-even mismatch because that is a very, very common thing to do. So do an element inventory, N equals 2, H equals 2. On this side, put your N straight across from the N on this side. N equals 1, H equals 3. So now, neither one of them match. So where do we start? Well, it says the one containing the most atoms. That's this one, which would work for this particular problem. But more important, what I want you to watch out for is this odd-even mismatch. 2 and 1 we're not so concerned about, but this 2 and 3 is a problem, and I want you to pay close attention as to why. Look at our 2 on this side. We can't ever put anything here that would make this a 3 on this side. No matter what number we put in front of this h right here, we can never make this a 3. We also can never make it odd. If we put a 2 in here, that would make it 4. If we put a 5 in here, that would make it 10. Anything times 2 is going to be even. So this side can never be odd, and this h is a 3 over here. So what you actually need to do is even this side up. You start by trying a 2. Even the odd side up. 2 times your 1 n is 2 here. 2 times your 3 is 6 here. Now come back to this side and see, now that you've made this one even, now that this is even, come over here and see if you can do something. 3 times 2 would make this a 6. And now our n is 2 on both sides. And our h is 6 on both sides. Our equation is balanced. Look for that odd even mismatch and make the odd one even, and then try and balance it. Is a very good strategy to have. And finally, picking again, it's all about where you start. You can get there more than one way. It's not that big a deal, but you have better success the first try if you can start at the right place. So FE equals 1, H equals 2, and O equals 1. If you look carefully now, FE equals 3. The next element is O. If I write down O, I've got a problem. O is not across from H. You don't want to do that. You want to have H is across from H's, O is across from O's. So the next one on this side is H. H equals 2, and O equals 4. So the H's match, but the FE's and the O's don't. So where do I start? I could put a 3 here in front of the FE and make that a 3, but I can make FE at the end. FE's by itself. It's not the formula containing the most atoms. I can put whatever I want in front of FE and make it be any number because there's nothing else attached to it. So that's actually where we want to go last. What we want to do first is change the most complicated one that needs to be changed. And that ends up being this one. We've got more FE's on this side, same 2's, more O's. So we need to increase our O's. How many O's do we want to have? There's 4 on this side, so let's try a 4. 4 times 2 changes our H's to 8. 4 times 1 changes our O's to 4. Now we come back over to this side and look, can we make our H's be 8? We can put a 4 times 2 is 8. So we're good here, we're good here. And now last, our FE, because it's by itself, whatever number we need, we can do it. 3 times 1 is 3. And now we're 3 to 3, 8 to 8, 4 to 4. Check. Okay, you've got some practice problems to do now. I'm going to show you that worksheet, and then you're going to work on those. Oh, first, we're going to talk about the parts of a reaction. Again, remember that you labeled these yesterday in your homework. A reactant is the stuff that gets changed, the stuff at the beginning of a reaction. A product is the stuff at the end. This is yields or produces. These reactants yield or produce. That's what the arrow means. These products. A coefficient is the number, the big numbers in front of things, and a subscript is the little numbers after it. So in your practice problem, it asks you to do that. What are we going to do in this practice problem? It says to circle each subscript, draw a square around each coefficient, and then basically do an element inventory. For example, if H2O was 1, circle the subscripts, so I would circle that, draw a box around the coefficient. There isn't one, but it's 1, it's not written. And then how many H's and how many O's might be the question. H equals 2, O equals 1. So for this first part, that's what you're going to do. On the second part, you're going to label the parts of a chemical reaction, which I just reviewed. And on this part, you're going to balance equations. I'm not going to do any more. If you need help with this, come see me and I will help you. But try to do just like we've been doing, element inventory on both sides, and then change coefficients. I will have an answer key for you, and it will look something like this. Like for the first one, it might be, well, I'll do the first one. So H equals 2, O equals 2, H equals 2, and it's one that we already did anyway. O equals 1. We put a 2 in front of here, and that gives us 4, and 2, and then we put a 2 in front of there, and that gives us 4, and we're balanced. So the final answer for this on the answer key is going to be 2, 1, 2. Remember, if it's not written, there's a 1 there, so then you know where they are. So 2, 1, 2, and you have to do more than just put in the coefficients. You need to show your element inventory, but that's how you check your answers. This one is 2, 1, 2. While I'm thinking about it, let's go ahead and number these. We'll number across this way. 1, 2, 3, 4, 5, 6, 7, 8. Is there any more? I forget. Please go down. Yes. So 9 and 10. Just keep numbering across. So I'll have an answer key for you in class to check your answers. Come see me if you don't know how to do this.